Okay. Here for the defactorization, we consider sine of a plus a. Again, we consider the compound angles a plus b and a minus b. Using these two, we define this formula. Okay. Here in the first, we consider sine of a plus b plus sine of a minus b. Remember, here both the signs are given. Both the signs are given. Compound angles are a plus b and a minus b. And in between these two, we have a plus sign. If we have a plus sign, then we consider 2 sine cos. We consider 2 sine cos. So here I write 2 sine A into cos B. 2 sine A into cos B. Then in second, we consider sine of a plus b minus here sine of a minus b. Again, if we have both the signs, and in between these two, if minus sign is given, then we consider 2 cos sign. We consider 2 cos sign. So here 2 cos A into sine B. Next, in third, we consider the cosines. Here cos of a plus b plus cos of a minus b is equal to. Both cosines are given. In between these two, addition, that is plus sign is given. If we have a plus sign, then we consider 2 cos cos. 2 cos cos means 2 cos A into cos B. Then in last, here in the fourth, we consider cos of A minus B. Here we consider minus sign first. Remember, here A minus B in first given. Then with minus sign, here cos of A plus B. Okay, again remember the arrangement. Here in the first, compound angle is A minus B, and in second, here A plus B is given, and in between these two, here minus sign is given. If we have minus sign in between these two, here for in the formula, we consider 2 sine sign. We consider 2 sine sign, that is here 2 sine A into sine B. So these 4 are for factorization formulae. These 4 are for factorization formulae. So these are also very important to solve the examples. Okay, then we go with our next part, and in that we consider double angles. Formulae related with the double angles. Double angles. Okay, double angle means we consider if theta is the given angle, then double angle for this theta is 2 theta. Double angle for the given theta is 2 theta. Okay, so here we consider formulae related with the 2 theta. Let's go with first one, and in that we define sine 2 theta. Sine 2 theta. Here everyone knows sine 2 theta is here 2 sine theta into cos theta. Sine 2 theta is what? Here 2 sine theta into cos theta. If we consider the half angle, that is half angle formula here related with the sine theta, using this double angle formula, here I write sine theta as here 2 sine theta by 2 into cos theta by 2. Remember this point. Now we go with second one, and in that we consider cosine, that is cos 2 theta. Cos 2 theta. Here for cos 2 theta our formula is here cos square theta minus sine square theta. Remember, cos 2 theta is what? Here cos square theta minus sine square theta. Then here next, here for cos 2 theta we have 3 formulae. We have 3 formulae. Here in the first, sine and cosine are given. Then in the second, we consider cosine only. then in the third we consider sine only. If we have to consider the cosine, your formula is 2 cos square theta minus 1. If we consider the sine, your formula is 1 minus 2 sine square theta. 1 minus 2 sine square theta. Okay. If we have to consider this cos theta in the form of tan, here I write this as 1 minus tan square theta, this divided by 1 plus tan square theta. Remember, here if we have to write cos theta in the form of trigonometric ratio tan, here I write this as 1 minus tan square theta upon 1 plus tan square theta. 1 plus tan square theta. Similarly, here for sine to theta, okay, here for sine to theta we have a formula in the form of tan, and here is I write 2 tan theta, this divided by 1 plus tan square theta. So remember this formula also, and this is for sine to theta. For sine to theta, here for sine to theta 2 tan theta upon 1 plus tan square theta, and for cos to theta here 1 minus tan square theta upon 1 plus tan square theta. Now here for third, we consider tan to theta. Okay. Here formula is 2 tan theta, this divided by 1 minus tan square theta. Tan to theta is what? Here 2 tan theta upon 1 minus tan square theta. Okay, so these three are also very important to solve the examples. Now we go with our next formula in fourth, in this side. Okay, here in the fourth we consider 1 minus cos to theta. If we have the minus sign in between 1 and cos to theta, your formula is 2 sine square theta. If we have a minus sign, then we consider sines, and if we have plus sign, that is 1 plus cos to theta, here in the formula we consider cosines, that is 2 cos square theta. So remember these two also. Okay, now we go with next part, and in that we define the trigonometric equation. And solution for the trigonometric equation. Here for the trigonometric equation we consider trigonometric functions. Let us see some example to define the trigonometric equation. If we have here in the first sine theta plus 2 cos theta is equal to 1. Sine theta plus 2 cos theta is equal to 1. This is the trigonometric equation. Since in this equation we consider trigonometric functions, and we consider equality in between these two, equality in between LHS and RHS. Let us see second one. Here in the second we consider here root 3 cos theta plus sine theta is equal to 0. So this is also the trigonometric equation. Since here we consider the trigonometric functions, also we consider equality in between LHS and RHS. So here for this type of trigonometric equations, if we have to find the solution, then here we have two types of solutions. Here first is a principal solution, and second is general solution. Principal solution and general solution. So here for the principal solution solution, remember here our solution means given angle here always lies in between 0 and 2 pi. 0 and 2 pi. If our angle is theta, here this theta is lies in between 0 and 2 pi. That is 0 is less than equal to theta is less than 2 pi, and this is for principal solution. This is for principal solution. Okay, so remember this definition. Then we go with our next part, next type of solution, and is here general solution. General solution of trigonometric equation. This point is also very important. Is also very important. Now here these solutions consisting of all possible solutions. Consisting all possible solutions of trigonometric equation is called the general solution. Remember, here for principal solution we consider some solutions, and here for general solution we consider all the possible solutions. All the possible solutions. Okay, here if our first form is here sine theta is equal to 0. Our first form is sine theta is equal to 0. This is our trigonometric equation. We have to find the general solution for the given equation. Then here general solution always in the form of here theta is equal to n pi. Theta is equal to n pi. Okay, and here n belongs to z. N belongs to z. Then if we have a form here cos theta is equal to 0. If we have this type of equation, here general solution is of the form here twice n plus 1 into pi by 2. Twice n plus 1 into pi by 2. Here also n belongs to z. So here this is our principal solution. Here our solutions are depending on n. Here we get number of solutions since n belongs to z. Okay, then here in the third we consider tan theta is equal to 0. Tan theta is equal to 0. If we have this type of trigonometric equation, our general solution is theta is equal to n pi. Here also n belongs to z. Here also n belongs to z. So remember these three also. Remember these three also. Okay. Here for remember here for sec and cosec, general solution is not exist. Okay. Then we go with the next point, fourth, if we have a form like sine theta is equal to sine alpha. Remember, if our form is like sine theta is equal to sine alpha, then here theta is always, here for the general solution our theta is like, our theta here is like n pi plus minus 1 raised to n into alpha. Remember, sine theta is equal to sine alpha for this equation. Here theta is what? That is general solution is what? Here theta is equal to n pi plus minus 1 raised to n alpha, and here n belongs to z. N belongs to z. Then here in the fifth we consider cos theta is equal to cos alpha. Cos theta is equal to cos alpha. Here for this type we consider theta as equal to twice n pi plus minus alpha. Again here n belongs to z, and here theta lies. Here alpha is what? Alpha is lies in between close interval 0 to pi. Alpha. Remember here alpha. This alpha is the principal solution. Alpha is for principal, or is having principal solution. And using this we find the general solution. Now we go with third one, sixth one. Tan theta is equal to tan alpha. Here for this type, our principal solution is like, here theta is equal to n pi plus alpha. N pi plus alpha, again this n belongs to z, and this alpha is belonging to open interval minus pi by 2 to plus pi by 2. Then next, here for seventh, we consider sine square theta. Sine square theta is equal to sine square alpha. If we have this type of form, here theta is n pi plus minus alpha. Again here n belongs to z. Similarly for here cos square theta is equal to cos square alpha. Theta is also here n pi plus minus alpha. And for last, here tan square theta is equal to tan square alpha. Again, general solution for this is, here theta is equal to n pi plus minus alpha, and here n belongs to z. So here for sine square theta is equal to sine square alpha, cos square theta is equal to cos square alpha, tan square theta is equal to tan square alpha. General solution is 1. Here theta is equal to n pi plus minus alpha. For these three, n pi plus minus alpha is for general solution. Okay, so in this lecture, up to all these points, we consider the principal solution and the general solution. Now we go with next part, and in that we consider sine rule. This sine rule is also important. Sine rule. Here for the sine rule, we consider one triangle. To define the sine rule, we consider one triangle. Here triangle ABC. Remember, these three are angles. ABC are the angles. Now we consider the sides. Here remember, here opposite side of angle A is A, having length A. Opposite side of angle B is B, having length B, and opposite side of angle C having length C. So here A, B, C are for length of the sides, and capital A, B, C are for angles of the triangle. So here in the sine rule, remember, the sides of the triangle are proportional to the sines of the angles. I repeat, the sides of the angles means A, B, C are proportional to the sines of the angles opposite to them. That is, here we get relation A upon sine A is equivalent to B upon sine B equal to C upon sine C, and is equal to constant K, and this is our sine rule. Remember this rule also. So here sides means ABC are proportional to the sines of the angles means sine A, sine B, sine C, and we consider this relation for sine rule. Now we go with cosine rule. Again, here to define the cosine rule, we consider the angles and the sides of the triangle. Here again, if A, B, C are the sides of the triangles, then capital A, capital B, capital C are the angles of the triangle. Then here our first important relation, A square is equal to here B square plus C square minus here 2BC into cos A is for cosine rule. Remember, here A is our length of one side, and opposite side we consider B and C. Here opposite side we consider B and C sides only, and we consider the angle opposite to the side A. Angle opposite to the side A, having length A. Then in second we consider B square. If we consider B on one side, then in opposite side we consider A and C. That is, here A square plus C square minus twice AC into cos of. Here if length of the side is B, here we consider angle B. We consider angle B. And in last, here in the third, if we consider C square, here on opposite side we consider A square plus B square minus twice AB into cos of. Here if C is given, on opposite side we consider angle C. So these three are for cosine rule. Remember this cosine rule also. And in last we go with projection rule. Projection rule. Projection rule. Okay, here for again projection rule we consider angles and sides of the triangle. If we consider A on one side, then in opposite side we consider B and C and angles related with B and C. Okay, so here B cos C plus C cos B. Remember, here small c is for length of the side and capital C is for angle of the triangle. So A is equal to B cos C plus C cos B. Then if we consider B on one side, then in opposite side we consider A and C. Okay, so here A cos C plus C cos A. And in last, in third, if we consider C on opposite side, one side, small c means length of the side, then in opposite side we consider A and B, that is here A cos B plus B cos A. So this is our projection rule. Here for the projection rule we consider the relation of angles and sides of the triangle like this. So here we define sine rule, we see cosine rule, we also see the projection rule. So in today's lecture we see some important formulae related with the trigonometry. These formulae or these rules are very important to solve the examples of competitive examination. Thank you.